brief understanding of what is a pod, and then we will be understanding about the namespace, and also we'll be understanding about the paints actually, how to apply a paint to a pod or to the node actually, particularly to the node, how we apply a paint to the node actually. Okay, so these are the topics we'll be covering up today. Okay, we will see how it goes actually. If you're not able to cover, if any one topic is left, we will take it the next day. Okay, so this is what the agenda is. Okay, so now what is a pod? So yesterday I was saying that pod is nothing but it is a smallest deployable unit in Kubernetes system, right? So that's we call as a pod. We define a pod is nothing but it's a smallest deployable unit in the Kubernetes system. Okay. Now, whenever we want to deploy an application into the Kubernetes system, we can deploy an application with the help of a pod actually. So if we go with the diagrammatic way or in the pictorial way, so we say that actually like whenever you want to deploy any application, we deploy with the help of a pod actually. So if you have a pod like this, inside a pod, you would be having a container running. So this we call it as a container, right? And as we know, like we install the Docker, right? So basically, a Docker would be the container. Docker is the one which is going to create a container. So whenever you want to run any application, the application can run, or any kind of a microbase application has to get executed in your Kubernetes system. It can execute it via with the help of a pod actually. Now this is the outer boundary or the layer, we call it as a pod actually. So what we can say that is nothing but a pod is nothing but it is a outer layer, right? It's an outer layer, it's just a layer kind of a stuff which is being made. And inside a pod actually, there would be a container which would be running. So within a container, we know that we have some kind of an image which would be running, right? So basically that image will be an application image, right? Or any kind of a customized image which you have built and you need to make it run that image. So you can run that image as a container, and that container would be created by the Docker, and the pod will be in turn created by your Kubernetes system itself, right? Kubernetes system means your API server is going to create a pod, right? It instructs to the controller to create a pod, that we know, right? So now what happened, right? So that's what we say, that this pod is nothing but it's a logical area. It's just a logical boundary or the area which is outside the container, and all the containers are enclosed inside the pod, right? So a pod can have more than one container. It can have even n number of containers. Suppose here I'm showcasing as a 2 containers. It can even have a single container, or it can even have a multiple containers also, like more than one container. Now, whatever the Kubernetes resources we have, like for example, we have a resource like storage, and we have something like a network. All these resources are shared between the containers like this. Suppose you have multiple containers, both the containers want to access the storage or some NFS storage or some networking. So both can have it can equally access these resources. Okay. And one more thing is that whenever a pod is created, so this we call the pod. So whenever a pod is created, a unique IP address will be assigned to a pod actually. A unique IP address is assigned to the pod. To know that in a Docker we saw, right, whenever we create a Docker, right, Docker will get created, Docker container will be up and running, the Docker will get an IP address, right, in case of Docker. Whereas here what happened, the container is number, it's a Docker container only, right? Here what happened, the container is not getting an IP address, but a pod is actually getting an IP address. So this is the difference you have to tell. So what is the difference between Docker and the pod? You have to say that Docker, whenever a Docker container is getting created, the container is assigned an IP address. Whereas in here in the pod, containers are not assigned the IP address. Only the pod is assigned an IP address, and that would be the unique IP address. So it means that now you can ask the question that Rajesh, suppose you have more than one container. Okay, how this container can be accessed by the outside world? It can be accessed with the help of the same single container. That's what this IP address is also shared between these two containers, or more than two or three, or whatever the multiple containers you have, right? All those containers can be accessed only with the same IP address. That's what only one IP address is provided to the pod. Okay. So this is what we say pod is nothing but it is a smallest deployable unit in your Kubernetes system, right? So that's what each pod will be assigned a unique IP address. Okay. So who's going to assign the unique IP address? You can say like within your, because the pods are getting created in your worker nodes. And within a worker node, we know that we have a kube proxy, right? Kube proxy is the one which is going to assign an IP address. Like that you have to say. Okay. Now, if you see, if I want to really understand some more detail about the pod actually, let us go with one more in the Kubernetes system, how exactly Docker works. We can just check now. Suppose I have a Kubernetes system. I have set up a Kubernetes cluster. Like we have set up Kubernetes cluster, right? Like for example, we have in the Kubernetes cluster, that we have a nodes, right? We have a master node, very well, and okay. We have a master node, and we have a worker node like worker node 1 and worker node 2, right? So this we call as a master node. This is master. This is nothing but the worker node. So I'll write it here something like a worker 1. This is our Kubernetes system, right? We already set up, right? And this is nothing but your worker node 2 or worker 2, we say, right? And this whole system is nothing but is your Kubernetes cluster, right? This whole system is not your Kubernetes cluster which we have set up. Now the question comes that, what is the necessity of a pod? That's the question comes. Why we need a pod actually? Like for example, you said that Rajesh, even in the Kubernetes system, whenever we deploy an application, or whenever we deploy an application, that application will be deployed as a container which is running inside a pod. Correct? Now, if you say that if my application is running as a container with the help of a Docker, it creates a container, then what is a necessity of being a pod? Right? So now let's understand that, like suppose like assume that like I don't know about anything about pod. Let us understand that I know only about the container. So Docker is one container technology I can use for deploying an application, right? Suppose assume that there's no pod concept over here in the Kubernetes system. I have only the Docker. Now how it happens? Suppose for example, I want to run 2 Docker images, right? 2 Docker containers. Like for example, if I say Docker, very well, right? We used to run this Docker container run, right? What is that? -FN name. Suppose if I say MySQL, right? And -FN name is suppose like a DB server, and the image name is like MySQL, right? Very well, right? We used to run this command when we are learning the Docker, right? So when we execute this command, what happens? Right? What happens, right? It is going to create a container. In that container, it is going to run a MySQL image. Correct? So now what happened? Assume that in your worker node 2, this container is getting created. Docker container. So what this Docker container has? This Docker container has the MySQL image or the DB which has been running. And every every container has assigned an IP address, right? The Docker will assign an IP address. So assume that it assigns IP address like 10.170.50.1 something. So this is the IP address which has been assigned to this container. Now assume that, let me create one more container. Suppose for example, if I say like something like this, Docker container. So this is, I'm talking in terms of containers actually. Still we are not come to the pod. I'm just telling you, like I'm just giving you a background picture of why we need a pod actually. Okay, so assume that pod was not there. So I used to even only create the container. Now you say that if now what happened, I'm going to create one more container, Docker container run hyphen name, like application server, app server, and I will use the application something like a WordPress application. So now what we will do, what this command will do, it is going to create a container. What is that container? It creates a WordPress container, correct? WordPress container. WordPress container. And what it will do, it will assign an IP address. What is IP address? Assume that it has an assigned an IP address as 10.170.50.2. Something, it has assigned this IP address, right? Now what happened, right? You know very well that whenever the WordPress application it has to run, it has to get binded with some DB, right? Like for example, MySQL or any other DB, right? It has to get connected, right? So to work with, it has to get connected. It has to get connected to some DB. And here we have a container which is running in a worker node 2. That's a MySQL DB which is running. Now, what will happen, right? If you want to make it integrated, you need to bind the IP address of this MySQL to the WordPress. So that we know very well, we have seen in Docker that you have to just do a binding of your MySQL, this contains IP address, to the WordPress. So once you do a connectivity, once you bind it, what happened, right? Whatever the data which is written in the WordPress, the data will be saved in your MySQL database, DB, right? So this is what it has been normally it happens. Correct? Till here you have any doubts, guys? Till here any doubts you have? This is very important which I'm discussing now.
No, Rajesh.
We should have a clear understanding about all these things.
Yeah,
Okay?
Rajesh.
Okay. Now what is happening is that we know very well that MySQL has to get binded with a WordPress application because it is an app, it's an application actually. So that's what we bind the IP address of this MySQL container this to this WordPress. Okay, so this is okay, this is fine. Now assume that your MySQL DB container will get killed. It will get killed. Okay, because of some issue. Maybe there might be maybe some kind of a memory leakage might happen. Maybe there might be some kind of a high CPU utilization might happen, because of which what happened, the container might go down or it might get killed. Now what happened? Now what is happening is that you have lost the connection. The WordPress has lost the connection, right? So what we'll do now? Do you think that your Kubernetes system or something it is going to recreate this container, MySQL? No, right? It doesn't create it, right? It doesn't create it because we are using a. Suppose that you say, Rajesh, if I have been using Docker Swarm, okay, in that case, okay, I would say that okay, if you're using Docker Swarm, if this container is getting killed or if it is getting it is made down or somehow it has become down, Docker Swarm will going to recreate the MySQL container again. That in that way I can agree. Assume that I'm not discussing anything about Docker Swarm here. I'm only discussing about the Kubernetes, where what is happening is that you don't have anything like a pod, you are only having something like a container. So when this container get killed or if this container comes down, does the Kubernetes going to recreate the MySQL container again? No, it will not create it. Then what happened, right? A user or the Kubernetes admin, he has to manually come and recreate the MySQL container again. Now after recreating, what is happening? A new IP address will be assigned. Let's suppose assume that 10.170.50.10. The new IP address will be assigned. Now what happened, right? Your WordPress, it was actually binded to this IP address. Now it has to rebind with a new IP address because a new container has been created. So it means that actually in case of a Docker container, there is no automation where what happened, right? A recreation of the new pod will be taken care and all. That is not happening in case of a Docker. So this is one disadvantage actually, I have to tell you. So this is one disadvantage. Yeah, of course, if you're using some other method like Docker Swarm and all, yes, then it will take care of recreation of the. Still in that case also a new IP address will be created, right? The new IP address will be assigned to a newly created container, right? Then again you have to rebind it to the WordPress. So what is happening that there is no automation at all here. So you have to do it manually everything, and you cannot do it manually in the production or even when you're working on a Kubernetes, right? You cannot do that. There has to be some kind of an automation should happen. Even like the recreation of the container should also happen. So that is the reason what happened, right? A pod came into the picture in Kubernetes. What pod says. So let me remove this. Okay. Now what pod says actually that, suppose I want same application WordPress under MySQL DB, I want to create in the Kubernetes actually. So when it comes to Kubernetes, how I can actually create an image or how I can create a pod actually, you have to run a command kubectl. Okay, kubectl run. Okay, what is that? You have to be something like a DB server and --- image is equal to MySQL. Now, if you run this command or if you execute this command, what Kubernetes system will do? Kubernetes system is going to create a pod here. It's going to create a pod. So this we call it as a pod actually. Sorry. This we call it as a pod. POD pod. Okay, guys, it's going to create a pod. Now, what is happening that you have to understand very carefully that when the Kubernetes system is going to create a pod, inside a pod, it has to create a container which has a MySQL DB running, right? But before it creates a container for the MySQL, what the Kubernetes system will do, it is going to create one container which we call it as a there's a container with the name which is going to create even I've forgotten the name actually. What is the name? It will create one container. Okay, suppose assume that. Okay, just one thing. Sorry. I think that server has an image equals index. So tutorial reports. Okay, it's creating. Okay. So it is in the worker one. Docker container ls. If I execute it, yeah, it's going to create a container with the name pause actually. Okay, I've forgotten that name. That's all. Sorry. So it's going to create a container with the name as pause actually. Now, what the pause will do? It is a separate container which is created by before it creates an actual container. It always first create a pause container. So what it will do that after it creates a pause container, what will happen that what Kubernetes system will do that Kubernetes system is going to create some kind of a namespace actually, some kind of a namespace. The name could be something like something I will write it here. It's going to create a namespace. Okay, the namespace something like XYZ, some name. But just understand that some namespace it is getting created. So what it will do that whatever the namespace is there, right? The namespace, this pause is going to bind this namespace. It's going to bind with this namespace, or it runs under this namespace. Okay. Then what is happening is that actually, then what is happening? The Kubernetes system is going to assign a IP address to this pod. Okay. So it'll assign IP address, like suppose like 10.10.1.100 something. It's going to assign an IP address to the pod. And then what is happening? Even this pause container, which is running over here, it also bind to this IP address. It means that it's going to add this IP address, or it's going to have an endpoint of this IP address within it. Actually, later what is happening that what the Kubernetes system do now it says that okay, he needs a MySQL. Now again, what is happening is that it is going to create one more container here. Now this container will have an image which is of MySQL. This is what it happens that whenever Kubernetes system it want to create a pod, while creating a pod, before it actually creates a MySQL pod, it's going to create a pod for the MySQL with a container. It's going to first create a pause container, and once the pause container is created, then it's going to create a MySQL container. So one of the intro questions they'll ask her, okay, how many number of containers will be there in a pod? Minimum. How many number of containers will be there? You have to say that there will be a minimum of 2 containers. One is a pause container, which by default it gets created by the Kubernetes system, and other will be the whatever the image which or whatever the application which a user want to run, right? That container will be running. Now what is happening is that actually now even this MySQL, right? This MySQL image which is running, right? It will also be running under the same namespace actually. And even this MySQL can also be accessed by the same IP address. So that's the reason what happened, right? Whenever a pod is getting created, the pod will have a POS container. That POS container will be mapped or will be added with this namespace as well as with this IP address. So whenever the MySQL, whenever the other container is getting created, even this other container can also be accessed with the help of a POS container only through this IP address. Now what is happening is that a unique IP address will be assigned to the pod now. Similarly, now what is happening that you say that Rajesh, I want to now create the WordPress actually. How to do it? We'll say kubectl run not db web server web-server -f image is equal to WordPress. This is the command that actually we use it in our Kubernetes. This is the command. This is a specific command we use it. Okay, when we do this, when we execute this command, so what the Kubernetes system will do, same thing. It will try to create a pod here, a pod. But inside a pod is going to create one container, which it called as a POS container. Same thing, POS container. And what happened, right? Before it runs, actually, what is happening that it's going to create some kind of a namespace first. What is the namespace we'll be discussing? Suppose something like ABC, some name you are taking. Now what happened, right? Whatever the POS containers which is running, so it will be running under the same namespace. Now what happened? A container will be created, one more new container will be created. So that container will be having this WordPress image which has been running over here. WordPress. Okay. Now for this entire pod, actually, it is going to assign an IP address. So what will be the IP address? 10.10.10.1 something 200, anything. So this whole thing we call it as a pod set. Correct? Now, now what is happening is that actually we know very well that earlier, whenever the WordPress has to run, it has to get binded with this MySQL DB. But here what is happening that this container is not actually getting an IP address. The whole pod is actually getting an IP address. Right? Now, what is a significance of having a pod? Assume that your MySQL DB, it is getting killed or it's getting stopped. Now, what the pod will do, pod will recreate the MySQL container again. So when it recreates a MySQL again, it doesn't mean that a new IP address will be assigned. The pod will be same only. The pod will not get changed. But assume that the MySQL container goes down or due to some reason it gets killed. There could be some reason, like it could be a memory leakage, as I said, or it could be some CPU usage, more CPU utilization happening, or it is not properly responding. So it might go down or it might get killed. So the pod, what it does, that pod will going to recreate this container. So while recreating a container, a new IP address is not assigned. The same IP address is used. That's the reason now what is happening is that what the WordPress will do, now whenever it wants to communicate with MySQL, it binds with the pod IP address. It binds to the pod IP address. Now what happened, right? We have achieved a redundancy now. It means that even though MySQL is going down, no need, the pod will take care of recreating the container again. And while recreating, what happened, right? It doesn't assign any IP address, same IP address should be used. And then in case of a Docker, what happened, right? When the MySQL DB went down, like you manually or through some way you used to recreate the container, but while recreating a container, it assigns a new IP address, and that IP address again you have to rebind it back to the WordPress. So what happened? It was a difficult task, or it is not a good practice to rebind the IP address again and again, right? Whereas here there is no need of rebinding an IP address. Till here, are you clear, sir?
So Rajesh, like what is the role of namespace then?
Namespace, I will tell you. We have not yet come to the picture. We have not yet come to the what is namespace. I will tell you later. Just try to understand that Now, whenever any pod is getting created, sir, the pod will be running in some namespace. That is what you can understand here as of now. So whenever any pod is running, it has to run in some under some namespace. Okay.
Okay.
So what
So
is the
the
namespace? Something like a logical boundary through which, or
okay.
it is something like it's a virtual cluster. It's like a boundary where it will be creating a. You can run any kind of a pod, anything within that namespace.
Okay. So the IP address what will be assigned like 10.10.1.100
Hmm.
that will be to the pod or to the namespace? To whom it
No
will be actually?
namespace. It does no. The IP address is for the pod, sir. Namespace is
Pod only.
something like
Okay.
yeah, pod only. Pod only will have a unique IP address, not the
Okay.
namespace. Namespace is something. It's a
Namespace is
logical
just
bound.
like a logic yeah, boundary, correct?
Yeah, it's like a boundary, or you can call it as a virtual cluster. So, what is a namespace? We will let it. Soon we will come to that now.
Okay. Okay.
Okay.
Mhm, mhm.
So now what is happening? That now what happens? Some kind of an automation here you have achieved, because like even though MySQL is getting down, we know wherever the pod is going to recreate it. Fine. So that is okay. Fine. Now one question will come to your mind now. Suppose you will say that Rajesh, the pod itself will go down. The pod itself is getting deleted or it goes down actually. Then what will happen? Supposing the whole pod will go down, right? So in that case, what has to be done? Actually, now what happened? Till now, you are maintaining a redundancy of the container with the help of a pod. But if your pod itself will go down, now you have to maintain a redundancy of the pod itself. Correct? The pod itself. It means that if the pod is going down, if the pod will be get killed, the pod has to get recreated. So in Kubernetes, how the pod can be recreated? It can be recreated with the help of a deployment. What? With the help of some kind of a deployment. With the help of deployments, you will get to know all these things in the upcoming classes. What is deployment, what is services, and everything. So I'm just giving you a very high level picture what will happen. If the pod goes down, or you might think that if the pod itself will get killed, what will happen? Who's going to maintain a redundancy of the pod? Redundancy means who's going to recreate the pod again? So you have something known as a deployment. So with the help of a deployment, you can maintain a redundancy of the pod. If the pod is getting killed, this deployment is going to recreate the pod again. Clear, sir? Clear?
Yes,
Yeah,
Now,
Rajesh.
got it.
yes. Now, what is happening is that actually, like, you might say that Rajesh, if now what is happening is that you might say that Rajesh, fine, that is fine. It is going to recreate the pod. Correct. Now you say that Rajesh, okay, fine. This pod is running. This is having an IP address of 10.10.1.100. Fine. This IP address is been binded to the WordPress, but WordPress is running in a pod which is having 10.10.1.200. That's all fine. Now you say that Rajesh, if the pod itself will get killed, okay, if the pod itself will get killed, you are saying that one more pod will be recreated. Correct. Who's going to create the one more pod? The deployment is going to create one more pod. Correct. Now what is happening that this pod again will get a separate IP address. It might get an IP address of what? Can I get an IP address of 10.10.1 dot something, 201 something. Now what is happening? This is a newly created pod now, right? Who created it? Deployment has created it. Now again what happened? This pod again you have to rebind it again back to this one, right? You have to rebind again back to this pod, right? Or to this WordPress, right? Then where is an automation then? It means that again the manual stuff. You have to rebind it again, right? So to avoid all this, to avoid all this, sorry, to avoid all this, what happened, right? To maintain a redundancy of the pod, you create a deployment, right? So that is what, and to maintain a redundancy of rebinding, or to maintain the kind of an automation where you need not to do any kind of a rebinding back to back the new IP address which is being created to the WordPress or to this container, right? You have something known as a services. So services will be created on top of your deployment, sir. I'm just telling in a very high level. Don't worry now. We will have a separate session for this. We have something known as a services.
Just a second, Rajvel. Like deployments will be for the maintaining the redundancy of the pods, right?
Correct. Correct.
And services would be for
Services will be for example, that's what I said, right? What is happening is that if this pod goes down, The deployment is going to recreate the pod. That is fine. But while after recreating, it's going to create a new IP address, or it's going to assign a new IP address, right?
Okay.
That IP address, again, you have to rebind it back to the WordPress, right? Because this IP address is gone, because this pod has gone down, or it has deleted, or it has destroyed. So new pod will get created by the deployment. But again, it has to rebind it back, right? So you are somewhere you're missing an automation. You are doing a manual step. To avoid this, we have something on the services. Services should be running on top of the deployments. We say that. So this we call the services. I don't think I will just a little bit up here. I think we have to use
Just change
that.
some color, sir.
Yeah. Services. Yeah, I will change the color. Yeah, you're right. Actually, we have to change some color. Actually, it look good. So we have to create some kind of a services. So this we call the services. Now, in services, Kubernetes, it provides three types of services. Okay, what are those three types? Cluster IP, second is a node port, and the third is a load balancer. These are the three types of services which is provided by the Kubernetes. So don't worry about this, because we have a separate topic for clusters, and we have a separate topic for cluster IP, node port, and the load balancer. Now what we are doing, we are just seeing it from a very high level now. Now what is happening is that to maintain a redundancy of the pod, you are going to have a deployment. On top of a deployment, you have some kind of a services, and services we are having these three types actually: cluster IP, node port, and a load balancer. If we are using the type cluster service type as a cluster IP, now what Kubernetes will do, that Kubernetes is going to give an IP address to the services. What is an IP address? Something like 10.20.1.10, something. Going to assign an IP address to the service. Now again, the same thing over here, like it's going to assign IP address for the services. And right here, I don't have any space. 10.20.1.2 or 1.20 something. So this is the cluster IP which is being assigned actually. Now what is happening is that actually, now what will do that? Now what is the usage of this services is something like that. Suppose assume that this pod goes down actually. Okay, this pod goes down, or else, okay, now I'll tell you one thing. Now what is happening is that actually, now whenever the WordPress or this pod, it want to bind with this pod, because here MySQL is running, here WordPress is running. So basically the MySQL IP address or the pod IP address, it has to get binded with this pod where the WordPress is running. Correct? That's what we discussed, right? Now what is happening is that actually, instead of using the pod IP address, now what is happening is you can use the cluster IP. We can use the cluster IP address actually to bind it. Now we can use the cluster. This IP address can be used for binding to this. Now, for example, now what will happen is that actually that this service, right? This service IP, whatever we have, right? This service IP, this will get binded to the pod now. Actually. So what it means that actually now we know that actually, because if the pod is running, if the pod will get terminated or it get exited, the deployment is going to recreate the pod. Correct. Now when it recreates a pod, it's going to assign a new IP address. Now when it assigns a new IP address, again you have to do the rebinding now. Right. So in that case, what is happening that we are not achieving any kind of automation. Still there is a manual will come to the picture. To avoid this, we have something on the services. On services type, if we are taking up the cluster IP, what happened? IP address will be assigned to these services. So this will be the cluster IP. Now what is happening? Instead of binding this pod with this pod IP address, we are actually binding to the service IP address. Like that you have to say. Okay. Now what is happening is how the communication will happen. Now suppose the WordPress would want to communicate with the MySQL. Now what is happening that your pod IP address, it will send a traffic to this. It will send a traffic this IP, this service IP. This service IP will send a traffic to your this IP address, and this IP address has been binded to this IP address, pod's IP address, and that's how you are able to communicate with your from WordPress to MySQL. This is how the traffic goes like this. Okay, why? Because that here you are not using the pod IP address, you are using the cluster IP address. Now assume that in this case, assume that this pod got killed. Now what is happening is that this pod got killed. Okay. Now what is happening that now what happened? This pod got killed. What the deployment will do? It is going to recreate a new pod. It recreates a new pod, and it just for the newly created pod, it will assign some IP address. That's what 10.10.1 dot something like 201 or 101 101 IP address it assigns. Now, what is happening? You need not to worry it. You will say that Rajesh, do you have to rebind this IP address to the WordPress? No, it is not required. Why? Because right, you are not rebinding with the pod IP address. Now you are binding with your service IP address or the cluster IP address. Right. Now, what the services will do now? The service was actually binding with the 10.10.1.100, right? Because this pod got exited or got killed, right? Now, what is happening is that the service IP address will try to rebind with this newly IP address, with this newly created pod IP address. So in that way, you need not to worry. It means that till now it was maintaining an endpoint from this IP address to this IP address. Now pod is gone. No problem. Whatever the newly created pod IP address, it will going to rebind to this IP address. So here, what is happening that you have achieved an automation. It means that you need not to do anything. So it means that this cluster IP address will always be there because your WordPress is going to actually communicate with the cluster IP address, and in turn this will communicate with this IP address. These IP addresses are not getting lost here. This IP address will always be a permanent IP address. It will always be there, right? Only the pod, if it gets down, right, then the newly created pod will get a new IP address. That anyhow it get binded because whatever the endpoints are there for this IP address, it's going to add this endpoint to the service IP address. It's going to bind it. In that case, you are actually maintaining a automation way. It means that you need not to worry about it. So fine, settle here. This is how you need to have a services actually, and services we are having three types: cluster IP, node port, and load balancer. Clear, sir?
Yeah, I'm good.
Correct? Yeah. So now what is happening is that actually, suppose your service type, instead of you selecting the cluster IP, assume that you are selecting a node port. You say, no, Rajesh, I don't want the cluster IP. Okay, I'm not using, I don't want to use a cluster IP type, but I want to use a node port. That's a second way. That's the second method of the service. Then what will happen? What it says actually that you know that every worker node, right, or every master node will have an IP address, right? We know very well, right? We have an IP address, right? So every machine will have IP address. Suppose like if I say 192.168.0.1. So this is IP address for the worker one. Similarly, we have a IP address for your worker two. What is it? Suppose something same thing 192.168.0.2. This is IP address of the worker two. Now, if you say that Rajesh, I have a pod. To maintain redundancy of the pod, I have a deployment, and on top of the deployment, I have a services. And if I am using the service as a node port, actually, then any person, if you want to access the so for example, suppose assume that anyone, suppose as a Kubernetes user, you are a user, or the master node, it want to communicate with the WordPress, or the master node, it want to communicate with your MySQL. Can it communicates with this IP address, cluster IP address? It can communicate, right? So the master can actually, if you try to send any kind of a like a traffic to this IP address, this traffic will get redirected to the pod, right? Similarly, the master want to communicate with the MySQL, it can actually communicate with this IP address, this cluster IP, right? So if it sends any kind of a traffic from here to this IP address, any of this IP address is mapped to this pod, right? So the traffic will flow to this pod, right? So it means that any of the node within your Kubernetes, it can communicate with that particular pod with the help of the cluster IP, right? Because it is an internal IP address within your Kubernetes cluster, right? Any machine can communicate with this. If it want to communicate with that particular pod, it can make use of it. Now assume that I am a user actually who's sitting outside here. Suppose I'm a user who's sitting outside here. Hello.
Yes, yes,
Yes,
Rajveer.
I'm a user who's actually sitting here somewhere. I'm a user who's sitting actually here, and I'm in the net and I want to communicate with this pod actually. So what is happening is that in that case, what is happening that you have to use the node port actually. What node port says that actually whenever you are creating a service as a node port, what node port will do, right? Whatever the worker node IP address we have, right? It is going to it is going to bind a port also, or it is going to expose a port also to your worker node type address. It's going to expose a port also. Now, what will happen that a user, if it want to communicate with this WordPress who's sitting outside, right? He's going to he's going to just communicate over the net. From here, what will happen that it is going to communicate or is going to send a packet to this IP address with this port actually. And what will happen that actually whenever a user or whenever we use a service and the type of the service we'll assign as a node port, what will happen internally, internally the service is going to, even a cluster IP also will get generated automatically. You need not to worry. Now what is happening is that once it generates a cluster IP, what happened, this whatever the node port we are having, right, which is export with some port number, this will get mapped to your cluster IP. And finally, this cluster IP will be mapped to your pod IP address. So in that way, what is happening that when a user is sending a traffic, he's hitting to this IP address with this port, right? Automatically, what happened, right? It is going to send a forward the packet to this IP address, which is cluster IP, and finally, this IP address has been mapped to this pod. Actually, this is how it happens, sir. Actually, when it comes to the node port, actually. Okay. Now, why we are again? What happened, right? Why we have a cluster IP again? What is the usage of the cluster IP again as a service of cluster IP? You have to understand that suppose here you are having only one pod. Suppose you have a replicas of pod. You are having if you are enabled the autoscaler and you say that Rajesh, I want to have multiple pod of the same type actually. I need to have WordPress the same type. I need to have a multiple WordPress. In that case, what happened, right? You have a facility of doing autoscaling or replica with the help of a controllers like replica set, right? You can actually create a number of pods actually. And you know that each and every pod again will have an IP address. So this pod will have an IP address of 10.10.1.202. This will have a 10.10.1.203, right? Now what is happening? You are having n replica set. Now the same thing, what is happening that all this IP address, all this replica set, this will get added or it will get added within this cluster IP. It means that the cluster IP, this service which is of a type cluster IP, it will maintain all the replica sets pods IP address also within it. So in that case, what is happening is that actually whenever a user he hits to this IP address, this IP address has been mapped to this cluster IP address. Now what happened, right? Now you could see that it is not one pod, there are several pods are there. Now it will decide where to send the traffic. It might send the traffic here, or it might send the traffic here, or it can even send the traffic here. Anywhere it can send the traffic. That is what the usage of the cluster IP. It means that if you have n number of replica IP address, this IP address will maintain, or this service will maintain, it will add the endpoint of all the spots IP address within it. So that whenever the traffic comes, suppose you're hitting this IP address, it's not only one customer. Suppose assume that there are three customers are there. There are three users are there. All the three users are hitting to the same IP address. Now what happens that all the three requests are coming, right? It is coming to this IP address. From here, it is redirecting. From here, how it does? Okay, user one request, it will go to this pod. User two request, it will go to this pod. And user three request will go to this. It means that you are load balancing the network here, or you are load balancing the traffic here. So that is also one of the use case of your cluster IP. It means that whatever the n number of replicas are there, all those IP addresses are added within it, so that it's going to distribute the traffic equally among the pods which are here in the worker one. That's how the use of the cluster IP. So we are just trying to understand in a very high level. So we have not gone in detail. We will go in detail when it comes to this classes, right? Whenever we are conducting the services, right? These three ports will be doing that, right? Now, what is a load balancer actually? What is a load balancer? Now, Load balancer is something like, suppose if you are using the service of load balancer as a load balancer, what we'll do, right? Basically, suppose assume that in the Kubernetes system, I can create a load balancer actually. Like in the market, we have a lot of load balancer, right? FI load balancer or scaler, whatever. Suppose if I'm doing a if I assigning a load balancer, now what will happen in that actually that this load balancer, what happened, right? You have some unique public IP address will be given, right? What is our public IP address will be given? Some public IP address will be given, right? Suppose like 100.172.68.10. Some IP address is assigned, right? Now, what is happening that whenever you want to give any, you cannot give a application, you cannot give an IP address with the help of with the port exposed. You cannot tell the customer to hit this IP address with the port number like this to access the application. You cannot do like that, right? You cannot give. Basically, you will not give any kind of a port numbers or you IP address to the to the customers to access that application. Basically, what you will do, you will either share the only one single IP address you will share with him. You will say that you please hit to this IP address. So basically what happened, this IP address will be the load balancer IP address, right? So what you'll do if you're assigning a load balancer, now what is happening that this IP addresses, right, with the port, this will get added within your load balancer. So now what is happening that if a user, if he hits this to this IP address, what happened, right? Based on the traffic, what happened, right? The traffic will get redirect to any one of the worker nodes IP address with that port actually. And finally, this IP address will be has mapped to the service IP, and this cluster IP, sorry, and this cluster IP has mapped to the port. In that way, the traffic flows like that. And still more, you know very well that this, whatever the load balancer we have, right? This entry, it will be made in your DNS server, correct? So in the DNS, you maintain a record, right? What is the maintain? You record the maintain this IP address, 100.172.68.10. It is mapped to the record A, and what is the URL? www.rajeshsingh.xyz, something like that. This is my website, right? This is my URL actually. So what happened, right? Now you'll not give the IP address now, load balancer IP address you won't give. Now you'll give the URL. So what the customer will do, he want to access that application, he will hit the URL in his browser, rajeshsingh.xyz. Now what is happened that whenever you hit the URL, right, the request will go to the DNS. In the DNS, there is a record. Okay, he's hitting this IP address. Okay, there's a record A. We say that it has to point to this IP address. So this, what is this IP address? The IP address is not to your load balancer IP address. So what happened that the traffic will flow out to the load balancer, and finally from the load balancer it goes down to your pod. This is how it happens, sir, when it comes to load balancer. But here you know very well that load balancer is an external load balancer actually. This is not some kind of a load balancer which is provided by the Kubernetes. It is an external load balancer which you have to, which you have to allocate this load balancer. Now what happened, right? This was externally you have to assign. Now what happened since from last 2 years, right? What has happened, right? Kubernetes itself is providing a load balancer. So it means that if you have a pod, on top of a pod to maintain redundancy, if you are maintaining, you have to create a deployment. And on top of the deployment, if you have a service and the service type is a load balancer type, what the Kubernetes will do, right? Kubernetes itself will create a load balancer as a pod within your worker node itself. And that load balancer will have, it will based on the range, right? What are the public IP address range you give, that one of the IP address will be assigned to your load balancer pod actually, and that will play a role. Whatever we are seeing in the external load, that same thing it will play a role. So it means that internally a load balancer will be provided if you use the service as a load balancer. So in that case, you don't need any extra load balancer because Kubernetes itself is providing a load balancer. Clear, sir? So even we have a separate topic for this also, load balancer, separate topic for node port, and again for the cluster IP. We don't have to worry because this is a very big part, and most of the intro questions will be asked in this area only. So they'll ask you like, have you used cluster IP, node port? What is the difference between cluster IP, node port, and load balancer? That's a very common question they ask. So we just try to understand, sir, what is a pod, and just I showed you a pictorial, some kind of a pictorial understanding about like how things works in your Kubernetes system. Clear, sir? Now you know very well that we already discussed something known as a pod is nothing but it's a smaller deployable unit, and also you said that a pod can have even a multiple containers, right? Because what Kubernetes says, right? Kubernetes has given a provision that within a single pod, suppose it's a single pod which is there, within a single pod, assume that Rajesh, I have two pods actually which is running. One pod is a WordPress and other pod is a DB. WordPress, WP WordPress, and this is nothing but your MySQL DB. Is DB. So we can have two different containers running in a single pod. This is also possible. Here, what is an advantage of being that? Because like here, what is happening is that actually here you are saving an IP address. So earlier, what happened, right? See, a separate IP address was given for this pod where the MySQL is running. A separate IP address was assigned to the WordPress. But now here, what happened, right? In a single pod, you are having a multiple container. So both this MySQL as well as a WordPress, you are maintaining in a within a pod actually. This is also possible. So most of us, you could see that when the Kubernetes itself is providing this provision, why can't you use this provision? Here what happened, one advantage that what is an advantage of having a multiple containers? The advantage that actually you are saving an IP address, that is one thing. And the second advantage that actually you are actually reducing the latency. Now you know that like whenever the WordPress here in this case want to come to MySQL, see, so how the traffic has to flow here from your pod IP address, it has to go, it has to hit to the cluster IP. From the cluster IP, again it has to map to this IP, and from this IP again it is remapped to finally to this pod IP, right? So here you could see that there could be some kind of a latency when you are actually when the WordPress is actually communicating with the MySQL container, right? But here, whereas here, what is happening is that there is no latency here. It is because it is having a what is happening that because it is there in the same container it is there, right? The communication is very simple here. There will not be any latency. So that would be the advantage of having a multi-container. That's what we said. Now you say, Rajesh, suppose assume that Rajesh, I have a WordPress container. Okay, fine. This is writing some data. I want to store some data. You will say, right? So now you could say that Rajesh, okay, fine. I will say that I will have one NFS SharePoint, NFS storage. I will say. So NFS storage you can have, and you can easily map or easily you can bind this NFS storage to this pod IP or to this pod. Now you say that I am having a multiple pod, same interface. You can even actually, you can bind it to, you can again bind it to what? You can again bind to this pod. Now again you can bind to this pod actually. So you could see that now it become a very lightweight container, right? So whatever the data the WordPress has to store, it will not be able to store it here. It will be storing in some NFS drive, shared drive. But what happened? Only you are mapping it actually here. So this container or this pod become a very lightweight pod. So that is one of the advantage of making your application run under the Kubernetes system. That it will be always it will be a lightweight actually. Clear, sir? Till here? Okay.
Yes, sir.
Fine. Now, when it comes to this is the introduction of the pod, sir. Okay. So that's how, and we will see the practicals now actually. Okay. Now, if you remember, like I okay, I think I lost the connection. Okay, I have to log on to the servers. What happened? Something has happened. This. some network issue. Mm. I was using private, huh? I think I was using private. Sorry. Mm. Let's see. No, no, I'm using public only, right? What happened? Not able to connect. Something happened. Yes. Okay, let me connect. Oh, working. How come suddenly it stopped working? Okay. Okay. Some problem with the master. This is worker 2 and worker 1. This is the public IP. Copy it. Okay. This is worker 1. So let's see. I think I should be able to connect. Yes, it's working. There is some issue with the master. Not sure what is the issue. Let us reconnect again the master. So master public IP address is 184. Oh god, I think there is some latency, network issue there. Okay, guys. So I'm having a master and I'm having a worker 1 and worker 2. Okay, these are the worker 1 and worker 2. And if you execute the kubectl command, kubectl get pods, already we have executed a command to run the pod. Let me do one thing, let me delete this just to, so we know very well like how to delete it. You have to say kubectl delete and specify the pod, and you could say that specify your pod name. So if you say kubectl delete pod and web hyphen server, the pod will get deleted. Okay. If I execute the kubectl get pods, now you could see that there are no pods found in your default namespace. Okay. Now you have seen at the beginning itself you have seen that, okay, to just check what are the nodes are there, you have to say kubectl get nodes. Correct? So you are having worker 1 and worker 2 and you are having a master node. Correct, guys? Now what happened, right? All these 3 nodes are there, and this is a worker 1, worker 2, and I'm just executing the kubectl get node to just display it. Okay. Now to create any pod, as I said, like you can have a declarative method, or you can have an implicit method, or you can have a declarative method. Implicit method means through the help of a command actually. Declarative method means in terms with the help of a YAML file. In the last session we have seen, right, how to create a how to create a pod with the help of a YAML actually, right? So whenever I want to create a pod actually, you have to run command kubectl run, and you have to give some name. Suppose if I'm doing a web server, okay. And now what is happening is that if I have to say -fn image is equal to, I'll give some image name nginx. Now you could see that it says that it has created this pod with the same web server it has created. To check the status, I'll say kubectl get pods. If you execute the kubectl get pods, it will show you what are all the pods which are running in your system. This is a command. Now, okay, I don't think, let me even create one more pod. I will say kubectl run. I will send something, I will say db server is the name, and I'll give the same image. -fm image is equal to, I'll give same image in this. Right? One more pod we have created. Let me do it. Let me create one more pod. Kubectl run. I will say something like a prod-server -fn image is equal to nginx. So here right now we have created 3 pods. If I see that kubectl get pods, kubectl get pods. If I do this command, you could see that all these 3 pods are up and running. Okay, you could see even the age also, how long it has been running. Like that it will show. Now, if you want to see, okay, these are all the pods which are running, but in which node it is running actually. To see that, you can execute the command, same command, kubectl get pods -o, you have to say wide. If you execute the wide, it will show that this DB server pod, it is running on the worker node 2. Similarly, prod server is working on worker node 1, and web server is working on worker node 1. Like that way, it will give an information with the help of a wide command. Okay, similarly, the same wide it is applicable even for the node also. Suppose if I say kubectl get nodes actually, it will show which are all the nodes which are being there, right? What are all the worker nodes? Along with the master, it will also show you what are the workers nodes we have, worker 1, worker 2, right? Suppose if I use the same command, if I use a -o wide, now you could see that it will give some more elaborate information. It gives the information about the internal IP addresses of your master node, worker 1, worker 2. It will give some information also, and what is the image, OS image. You are using a Ubuntu image, and this is a kernel image. So it will give some more extra information with the help of a wide command, -o wide. Right, guys? So now what is happening is that, okay, whenever I want to delete any pod, so let me clear the screen. So if I say kubectl get pods, right? Suppose I want to remove the web server. I'll say kubectl delete pod web server. So I want to give with the name of that pod. So only this particular pod will get deleted. So if I say kubectl get pods, now you could see that now only 2 pods are there. Right? Now put 2. Now you say that I want to delete all the pods. I'll say kubectl delete pods -fn all. If you do it like that, all the pods which are running in your system will get deleted. If you're having some 10 pods, all the 10 pods will get deleted with the -fn all option. Now again, if you say kubectl delete, get pods, now you could see that there are no pods running in your system. Correct, sir? Correct? Now, you saw that, like we saw one thing, that whenever I create any pod, kubectl, okay, run, suppose something like app-server, and I'll just clear this -fn image is equal to nginx. So you could see that a pod got created. If I do the kubectl get pods, if I even do -o wide, now you could see that this pod is actually running in a worker 1. Actually. Now if I go to the worker 1, this is a worker 1 node, right? If I execute a docker container ls, Now you could see that your engine is actually running here. But before Nginx, you could see that even the pod container is also got created. You could see that pod is actually created before the Nginx container. Correct? See. So this what happened, right? These containers have been got created, and this container is actually running inside a pod. But here, what happened? With the help of a Docker command, I'm only trying to display what are the containers which are running the worker one. Correct. Now, what is happening is that you could see that the pause has been created. So this signifies that whenever you are creating a pod, actually, along with an actual image, even the pause will get pause container will also get created. So that's how it proves here that okay, pause will also get created. So whenever they ask anything, how many number of containers will be there, how many number of containers will be there, minimum containers will be there in each and every pod, you have to say minimum there will be two, right? One will be pause and other with the actual image, what is the image which you have given to run. So that would be the second container, right? Now we can even see it, we can even do a, like if I do a watch actually, watch, you are watching it. Now you could see that actually kubectl, no sorry, I think I have to be in the master, kubectl, kubectl, delete pod app-server. You're deleting the pod, sir. Now you could see that, okay, you lost that pod now, right? Means you lost the pod means you lost the container also. So the pause and that Nginx has gone now. Now again you try to run this kubectl run app-server. Now you could see here, see first pause was created, last 2 seconds. After the pause, you could see the Nginx has created, right? So in this way, you can prove that pause is getting created always. Whenever you're creating any container, always pause will be running inside, as a container will be running inside a pod actually. Like that you can see. Clear, sir? Okay. Now, so that's what, and we know very well that in the last class, if you remember, that we had created one YAML file, right? And with the help of a YAML file, we were able to run a container, right? And to write a YAML file, we have understood, right, how to write a YAML file and all. So basically, you have a three major important things. One is the API server, and what else? Other is a kind, right? Here you could say hello pod, right? You have an API version, you have a kind, you have a metadata, and you have a spec. Don't worry now, we'll be slowly getting into this of how to write. And last class we saw this, right? We copied this, and what are the things we did? If you remember, right, guys, I copied it, and what I did, I went to my master node, and if I if there is some network problem. Okay, I think I've lost the connection again. Oh, okay. So there's some serious network connection is happening over here. I think this is the same reason. I think yesterday also. Uh, I think we have lost the connection again. Maybe there might be some network fluctuation is happening over here. Okay. Okay. So guys, I think there's some network problem is happening over here.
Like in some between, we are losing you for like 5 to 10, 6 seconds, like that.
Yeah, yeah. Okay, guys. So I think what we'll do, we will stop it here, and tomorrow we will continue for longer time because I have to cover a lot of things actually. Because I have to cover the namespace and what is a taint, and also we have something on the label. We have our pod limits, pod resources, limits, and all are there. Like that. And we have a pod health checks, actually pod health checks. which we call it as a liveness, as well as a readiness. Like that. So these are all some of the very important things which we have to cover tomorrow. I don't think so that we will be able to cover everything by tomorrow. So, but we will be able to cover the namespace, taint, and the label. These are the three topics which we can cover tomorrow very well. So on Sunday's class, we would be covering up many more things. Okay. Once this is completed, then we can go with the controllers. So the controllers are mainly replica set, replication, like deployments, like that, and like daemon sets. These are all the important things when it comes to the controllers actually. So what we'll do, we'll stop it today here because of the network. We are unable to continue. We'll see it tomorrow, sir. So tomorrow we will be having a session at 4 o'clock, correct? 4 to 5:30. 4 to 5:30 or 4 to 6 we will connect tomorrow. Okay, sir.
Yes.
Sure. Thank you, guys. Thank you all. I think any one of you can stop it. Let me check if I can stop it.